There is a darkness drifting through our galaxy, invisible, silent, untethered. These are not stars, not planets, not comets or clouds. They are rogue black holes, the loners of the cosmos, wandering through space with no companion, no light, and no warning. Born in violence, powered by gravity, and shrouded in secrecy, these cosmic ghosts move unnoticed through the Milky Way, not anchored in a binary system or feeding from a bright accretion disk, but drifting alone, black on black. For decades, they've evaded detection. We know they must exist. But where are they? And more importantly, how close might they be to us? This is the story of rogue black holes, the quiet predators of the universe, hiding in the dark between the stars. When most people think of black holes, they imagine the terrifying monsters at the centers of galaxies, supermassive black holes devouring stars and bending time. Or perhaps stellar black holes, the remnants of massive stars gone supernova, locked in bright binary systems, feeding off their partners. But not all black holes live such predictable lives. A rogue black hole is a black hole that moves alone through space, unbound to any star, system, or cluster. It emits no light, gives off no signal, and unless it interacts with nearby matter or bends the path of light through gravitational lensing, it is all but invisible. They are cosmic nomads, wandering the galaxy without a trace. Astrophysicists believe that millions, perhaps billions, of these rogue black holes may be drifting through the Milky Way. Some are born this way, ejected during the chaos of stellar evolution. Others are kicked loose by galactic mergers, collisions, or gravitational slingshots. And we have only just begun to find them. To understand how rogue black holes come to be, we must first understand their birthplaces. Most stellar mass black holes form from the death of massive stars, stars at least 20 times the mass of our Sun. When such a star runs out of fuel, its core collapses under its own gravity, producing a black hole. But if that star was part of a binary system, the supernova can disrupt the balance, either destroying its companion or giving the black hole a violent kick, enough to eject it from its home. This natal kick can be thousands of kilometers per second, enough to send the newborn black hole careening through interstellar space, unbound to any object. Some black holes may also form from failed supernovae, where the collapse is so total, there's no explosive outward burst, just a quiet implosion. These silent black holes are even harder to detect. And then there are the recoil black holes, supermassive behemoths flung from galactic centers after merging. When two supermassive black holes collide, they can emit gravitational waves asymmetrically, producing a recoil effect that ejects the resulting black hole from its galaxy entirely. Imagine a black hole the size of millions of suns, hurtling through intergalactic space. It's not science fiction. It's gravitational reality. How do you find something that doesn't shine? Black holes, by definition, emit no light. We detect them indirectly, by how they influence their surroundings. In binary systems, we see X-rays from the hot material spiraling in. In galactic centers, we watch stars orbit invisible points. But a rogue black hole leaves little trace. The most promising detection method is gravitational microlensing. When a massive object passes in front of a background star, it bends and magnifies the star's light. If that object is a black hole, it creates a distinctive light curve, lasting weeks or months. In 2022, NASA's Hubble Space Telescope, in collaboration with ground-based surveys like OGLE and MOA, confirmed the first ever rogue black hole through this method, about 5,000 light-years away, with a mass about 7 times that of the Sun. It had no companion, no emissions, just gravity. It passed in front of a star and briefly warped its light, revealing itself in silhouette. It was a ghost, caught mid-glide. The Milky Way alone contains an estimated 100 million to 1 billion stellar mass black holes. Of these, only a tiny fraction have been detected. Many of the rest, perhaps the majority, are rogues. Stars are constantly dying. Supernovae occur roughly once every 50 years in our galaxy, and each one has the potential to form a black hole. Simulations suggest that 1 in 10 black holes receives a powerful enough kick to escape its birth system and go rogue. Others are formed in isolation or ejected from clusters through gravitational interactions. It's likely that rogue black holes are drifting between stars through the galactic disk and halo unnoticed. Statistically, there could be thousands within a few thousand light years of Earth, perhaps even one within 100 light years. And still, they remain hidden, silent, waiting. What would happen if a rogue black hole came close to our solar system? The idea is chilling, a massive object, undetectable to the naked eye, drifting through space. Would it devour planets? Rip apart the solar system? In reality, the odds are low. Space is vast. The chances of a black hole passing directly through the inner solar system are astronomically small. But the consequences of even a distant pass could be significant. A black hole passing within a few hundred AU, outside the Kuiper belt, but still gravitationally relevant, could destabilize the orbits of comets, asteroids, and distant planetary objects. Some theorists even speculate that the mysterious Planet 9, a hypothetical massive object causing orbital anomalies in the outer solar system, could be a rogue black hole. It's unlikely, but not impossible. A close enough rogue could also gravitationally lens nearby starlight or create temporary distortions in our view of deep space. In short, rogue black holes are not a clear and present danger, but they are a wild card in the cosmic deck. Finding rogue black holes is one of modern astronomy's greatest challenges, but we are developing new tools for the hunt. Gravitational microlensing surveys, projects like OGLE, MOA, and upcoming missions like NASA's Nancy Grace Roman Space Telescope will scan dense star fields in the galactic bulge, searching for the telltale signs of lensing events. Gaia, the European Space Agency's Gaia mission, maps the position and motion of over 1 billion stars. Tiny deviations in star movement, like invisible tugs, could reveal the presence of nearby black holes. X-ray and radio follow-ups. If a rogue black hole passes through a cloud of gas, it may generate weak emissions. Observatories like Chandra or the Square Kilometre Array may catch these rare flashes. Gravitational wave observatories. While primarily focused on mergers, instruments like LIGO, Virgo, and CAGRA may detect lone black holes colliding with compact objects or revealing their mass through stochastic backgrounds. The next decades will be transformative. We may not just find a handful of rogue black holes. We may map a population of them, learning where they came from and where they're going. Not all rogues are small. Galaxies collide, and so do their central black holes. During such mergers, gravitational waves ripple through space-time, and sometimes they kick the resulting black hole out of the galactic center. These ejected supermassive black holes can roam intergalactic space, carrying with them entire clusters of stars, like an island of light in a sea of dark. In 2023, astronomers discovered a possible candidate. A streak of stars seemingly formed in the wake of a runaway black hole, over 20 million times the mass of the Sun, hurtling through space. Imagine that. A black hole larger than any in the Milky Way, no longer tethered to a galaxy, dragging its own stars behind it like a comet's tail. These are not just rogues. They are exiles, monuments to cosmic violence on a scale we can barely imagine.